driver and the path of the exe we had downloaded. And then we said create a new object for me, WebDriver equal to new Chrome driver. So this driver is reference to the Chrome driver object. And using that Chrome driver object, we are navigating to a URL of our interest, driver.get. So then when we execute this, our Chrome launches and navigates to this URL, whatever we have specified, right? So this was our starting point of automation. So for any web application, we need to launch the web application into the browser, and then we continue further. Now, this was an introduction to Selenium, and we all know without good knowledge of core Java, we will not be able to continue or to good in automation, right? So we will now move to the basic concepts of Java. So Selenium, we understood that it's a tool to automate web-based applications, and how it is used, how browser is launched, we have seen. So now let's go back and our basics of Java, right? So as I have already discussed in our schedule, that we will do the introduction, architecture we will learn, and then do the setup and launch a browser. Then we'll go back to the introduction to Java, and there would be around 5 to 6 days we'll spend on fundamentals of Java, right? Because without knowledge of Java, it would be difficult for all of us to do any programming, right? So now the content of our Java would be like this. You can see the screen. So our first day today, we will have the basic OOPS concepts. Then it will contain the concepts, then abstraction and encapsulation, which are two more critical things. We will see how they work. Then in the second day, we will have the basic language constructs, what is variables, how Java variables are defined and used, class and objects, Java array tutorial. Then we will have arrays, then we'll have array of objects. So how do I create an array of objects? What is an array list? So this will be the next day. Then third day will be string, because string, in automation, the most widely used would be string. Okay, because all our applications, web applications, right, they have data, textual data on the UI. See, when you open Gmail or Facebook or any other application, whether it is your car application, right, where you buy a new car, you go to marutisuzuki.com or hyundai.com, everything on the website is printed on the application. We have to read those, right? So all mostly it will be strings. So we'll spend quite some time on strings. So I think that next 2 days we will be working on string, how the string functions are used, right? How do we manipulate the strings? How do we capture the strings correctly? Now, then after that, we will work with maps. So there would be some concepts where we have to use maps also. So we'll try to understand hash maps. And then we will go to abstraction and how abstraction is done in Java. Inheritance, polymorphism, abstraction. So we know these are the groups concepts, right? So now we'll go with abstraction and how abstract classes and interfaces are used. What is abstract class and method? What is interface and the differences? And then the next day we will do the exception handling. How do I use try and catch blocks, and what are the throws keywords? So there, how do I throw an exception? And then we will have some loops concepts. There are so many other things in Java, right? But we will go ahead with only with the core things where automation we need for automation, right? So in the condition loops, we will have for loops and switch statements. And then we will have some, if you have some time during the end of the training, I will help you with so many other things, and we'll have assessments later on. In Java, I'll ask you to write some basic programs just to assess you how you have fared, how you have understood the concepts of Java. Right, so now let's go ahead and understand the basic object-oriented programming concepts, right? So what is OOPS? So we all know, I think, whatever branch we have studied, so basic programming knowledge, I think everyone would be having. If we don't have, then also that's fine. I'll teach you, right? So uh, object oriented programming. So what do you mean by object oriented programming? So just to give a context, say for I'll open my one notepad. Right, and say uh, I have a bank application, right? Bank application, and my bank account number is 12345, and my balance in my account is say 1,000 rupees, right? Balance equal to, I will say, instead it will look good. Account is 1,000. Account is 12345. Balance is 1,000 rupees. Now, when if you go back 20 years, right? There were unstructured programming languages. How it would be? So what they used to do. So if there was any withdrawal or deposit happened in the bank, so what it would do? It would say balance equal to balance plus I deposited 10 rupees more, or say 100 rupees, right? And then I used to display that, print the balance equal to, and say plus balance, right? So we used to do like this. And then again there is another withdrawal, same thing I have to repeat, minus 50 or minus 100. I withdrew 100 rupees. I had 1,000, so I deposited 100. I displayed that, printed that for the customer. Oh, how much is my balance? So 100 and 1,000 and 100, right? Now again I withdrew 100 rupees. Again I will have to call this balance. It will show 1,000 again, right? Because 1100 minus again 100. So this BALANC, okay. So now this is how unstructured it is. Like you have to keep repeating, right? How many times we were used to withdraw and how deposit. Every time this was required. You can see it, how unstructured programming was. So there were unstructured programming languages when you go 20 years back, right? Before our even Pascal and all. So there were programming languages which came little later, which were structured. So before that, all our programs used to be like this. They used to repeat the things, and it was how the application used to work. Now this is unstructured programming language. Okay, unstructured language. Now after that, what happened? They understood, oh wow, this is a problem, right? So if you have to repeat this for 1 year, how many lines of code we need? We need thousands of lines of code we have to write just for 1 year. So they understood the problem. So they work, scientists or programmers, they work on refining things, and they introduce structured languages. So what structured language is introduced? They thought, okay, we see that there is a thing called balance and there is print, which is getting repeated. So they grouped that together, right? So what they did, this was the same, right? But then they created a small method, say so. So they created a method called so, and then they printed this balance, showed the balance. So what happened is, you don't need to call the again and again. So whenever there is a withdrawal, so what they did, so when the customer deposited something, call the show method. So they call the show method would be somewhere written separately, and then they used to call the show method, right? So there was a deposit, call the show method. Now they would be this one, and then again show method. So you see how little easy it became. Earlier it used to be a long print statement where you have to format and you have to show the balance, right, according to it. Now they separated that display of in a separate method they wrote, right? So now this will come here. I think it's already there. Yeah. So now this show method is called. So it looks clean, right? Balance. So balance. So we don't need to write the print again and again the complex long statements. So it helped a lot, right? But still we see the balance, deposit, and the withdrawal still happening again and again, right? We still see that they have to be repeated again and again. Now again, this has to, the person goes to ATM or goes to branch and withdraws some money or deposits some money, they have to put this again for that day and then call the show methods. So for that day, they will get these two show methods. If he has withdrawn 100 rupees, they will call this method and show the balance, right? So even though they did some structuring by separating this print into a separate method called show, there were still some repetitions happening. And for the same person, if I do it for 1 year, they have to repeat this same steps again and again, same lines, right? Many thousands of lines. Now came into picture to see, to solve this problem. This is called structured languages, right? Now came the invention or introduction of object-oriented languages. Oriented languages. So the introduction of object-oriented languages happened to resolve all the problems we had in our previous years. The problem with the structured language and problem with the unstructured language. So what did OOPS or the object-oriented programming languages bring? So what they did, they said, okay, the same bank application, I will create a template, right? So I will create a template called class, right? A class is a logical entity. There is no physicality about the class. The class is the logical. What the object-oriented programming languages did, it introduced a concept called class and objects. So what they did, they introduced class and objects to handle real life scenarios. They introduced class, and inside the class we would have objects containing the data and the methods, access to the methods. So they introduced this class and objects. So how will the now object oriented programming languages, we have so many, right? Java, Python, right? Ruby, all these languages were introduced with object orientation. So now they started with defining class and object. So what they did, they created a template of the bank application, right? So now say public Just don't strain yourself. It will be easy for you to understand. Public class, say bank, right? And then we had, what would a class contain? A class would contain, it is a template, a logical form, right? So I'll tell you in detail about class, but just to show you the difference of object-oriented programming language versus the unstructured and structured, I would say. So now it will be inside integer, we will say account number, right? And then we will have another balance, right? These two fields are required, and then we will have three methods, right? One would be withdrawal, this also is a public, and integer it would return, right? And then it would have some thing inside it, implementation of that method. Then we would have deposit, and then we would have one more method called display or show, and we close the class. See, now what happened is we created a class for the same bank application, which looks so logical, right? Instead of repeating anything, we don't need to do anything. We just have to create this template first, and then now create an object of this class, and say object would be say one person called Pranita. So what we will do, we will create an object of this class called bank b equal to new bank, right? So this b becomes the object of this class, right? Now this is a person's account, so a person account, this will be, I'll put a comment here, objects, right? Now any person accessing the bank application would be referring to the object. So now this b has its own account number. We can set the account number, right? B dot account number act underscore num equal to 1 2 3 4 5. Then b dot balance, there should be some initial balance, right, equal to 1000. And then he would simply say call, whenever there is a withdrawal, give me b dot withdrawal. So withdrawal, and then b dot deposit, and then b dot show. See how clean it becomes now, right? So no repetition. Just use these methods only anytime there is a withdrawal or balance, withdrawal or deposit. This is more than enough. Create the object of our parent class, right? Become an object of the parent class, and then you have your own personal data inside your object and your own methods from the parent class, which you can now define also, and we can use the implementation defined by the parent also, right? So this is how object oriented programming languages came, and they resolved the complexities and the problems that were there with other old programming languages. So this, you understood how simple things became. So you now let's come to class. So, right, what is a class? Are you able to follow, all of you?
Yes.
Anyone who is not understanding? What is object-oriented programming languages? What are the different concepts inside OOPS? So we will learn today, but maybe some of us are not from the IT background, so for them it will be a little complex. So are you guys all following?
Yes, sir.
Yes, sir.
Yeah. So
Yes,
very
sir.
simple. Right? See, it is a real life scenario, right? So when we work with class objects and all, it looks like that we are handling a real life object, a car, right? Car is a class. But then when you come to different variety of car like Maruti or BMW or Hyundai, so these would be objects, right? So car is a template, means it would have a engine, and then it would have wheels, and it would have a function to drive, to accelerate, to reverse, to do parking, right? Anything. What is, and those are the functions we perform on the car. So car as a whole is a class, and then when you define a object of that class and say BMW is an object, Maruti Suzuki is an object, Hyundai is an object, right? So those objects will implement the same driving in a different way, right? Hyundai would have a different way of driving. The internal engine would work differently, whereas Maruti's engine would work differently, and then BMW's engine work differently. We know that BMW is a costly car and it drives fast, right? The fuel consumption may be high, but the power it gives out would be more, right? So BMW as an object has implemented the driving method in its own way, right? Similarly, Maruti also has its own way of implementation, and Hyundai also has its own way of implementation, right? So now, where was that notepad? Okay, yeah. So now, what are the concepts? Class, objects, then we have uh, inheritance, then we have uh, polymorphism, then abstraction, inheritance, polymorphism, abstraction. What else? Aggregation,
Encapsulation.
encapsulation. Thank you. And
Interface.
interface will come. Interface is a type of encapsulation. Okay, so it comes under encapsulation. So class, objects, inheritance, polymorphism, abstraction, aggregation, encapsulation, and I think one more concept is there. We will, if I remember, I'll tell you. But these are the core. These are the main important things of object-oriented programming language.
Exception
Right.
handling.
Exception handling is not part of OOPS. So exception handling is, I mean, to say, how do you catch errors, right? So how do you say, for example, you are running a program and you see a element not found exception, right? So when we do automation, right? So automation is generally to find objects on the web application. So suppose I'm trying to click a login button. After entering my user ID and password, I am clicking on the login button. But login button, when I click, it does not click, right? So that is a real life scenario of an automation engineer where sometimes the Selenium's click method does not click the object, click the button. Right, that time, if you see in the error logs, you will see element not found exception. So those are exceptions. So that is not part of OOPS, right? So OOPS concepts are these core concepts of programming, right? So association, I think one more is there. Association, I think, yeah. Polymorphism, association. So these are the basic concepts. So now let's come to class. Right, class. What is a class? I told it is a logical entity. Logical entity means it is a template. template. Okay, what other names you can give? It is the frame, you can say, right? So now we all were students, or are some of our still students, right? So say I was from electronics branch and I was from 2022 year, right? So my class of electronics 2022, electronics 2022 batch. So this is one example of a class, right? It is really a class. We used to go to a classroom and study, right? So electronics 2022 batch is a class. Now inside that, all the students were the objects, right? So any student of that class, say Pranita, am just taking a name, right? Pranita, then Shubham, then Mahesh, right? All these people who were part of electronics 2022 batch class are objects. How people know about them? What are you doing? I am doing electronics. In which year you passed out? I am from 2022, right? So uh, they go to a class to study, right? So what class? Electronics 2022. Inside that there can be multiple subject classes, but that's the room would be the same, right? The different teachers would come in and start teaching, but it would be one allocated room inside the college where the students go and study. Similarly, in object oriented programming world also, it is the same thing they have implemented as class. Class is a name given to a group of objects, similar objects, right? I cannot bring here Maruti, right? So Maruti, if I bring, that's a car, right? I cannot bring until it is not a name of a person. If Maruti car, if I mention, I cannot bring Maruti along with the students, because students are human beings, right? All these have a human properties, but this car is not a human. So I cannot bring it here. So if it is a group of similar things, which is having similar properties like human beings grouped together into a student classroom class, or then we can have another class called car, right? Inside that car I can bring, now I can bring Maruti, Hyundai, right, or BMW, or Mercedes, or any name you give, Rolls Royce, right? So this was a class where students used to, similar type of students, right? They all belong to the electronics 2022 batch. So that was a class. Whereas this class is a class of cars. So it defines what it defines. It defines different type of car and their different functions, right? So this is how the real life world of students or cars or anything given is easily handled in the concept called class, right? So we saw it. It's a logical entity. So we give a structure. Okay, now electronics 2022 batch, I will have 50 students, similar 50 students, right? I cannot bring seniors, I cannot bring juniors, I cannot bring teachers inside that. Only students of electronics 2022 branch will be form a class called electronics 2022 batch. They will have, what they will do? They will study is one method. They will take a break. There is another method. They will do some functions, programs, parties. That will be another method, right? So, and what type of data they hold? They hold their names, their age, their attendance, right? So these people, I'll remove this or move it further down. Now class contains data and methods to work on the data. And they hold these two things, data and methods to work on that same data, what they are holding. So data would be, for the above class, example, electronics 2022 batch, would be name, age, right? Hobby. Then what would be then? Any feature of a student, right? Orientation, or in what do you say? Hometown. They belong to address, local address, right? So all this they hold. All the students have this data, right? And now methods would be what they will write methods, right? Say they will study, right? If people are bunking, then that they will not call this study classes, right? Mostly all the students study. So study will be one method, then breaks will be one method, right? Then uh, exams will be one method. We give exams, right? The students will give exams. And then we will have vacation. Then we have uh, prep exams, right? All these are the different methods which the same people would perform. So these methods work on these data only, whatever the data the objects hold, right, inside the class. So very simple now it becomes, right? A class, a logical entity, and they are they have a that's the template given to any object, right? Now if I ask Pranita, what are you, right? So she will directly say I am a student of electronics 2022 batch, right? So it's so easy to tell what the person is. So it says, okay, oh yeah, she is a student of electronics 2022, so she must be doing such and such things, she must be holding such and such data. Similarly, if I say for the car class, uh, if I ask a Maruti car, then the Maruti car would say I belong to the car class. So we know car class. So car has a name, a type, a company name, what type of car it is. It's a hatchback car or a sports car or a off-roader, right? Different type of cars are there in market. So we get a clear picture in our mind when I say I belong to this car, to this class, a car class, right? So it becomes so clear. Now we hope we got the idea of class and objects, right? So object would be an instance of the class, right? So what is an object? So we had this object, we had this class, logical entity, template or a frame, right? And then we have objects. Object is an instance of the class. Instance of the class. Instance of the class. Right? So it's clear, class, and then we have objects which belong to the same class. The class is just saying, okay, this is your structure you have to follow, and objects will follow that structure. They follow the electronics 2022 batch structure, and that they hold the properties of that class, right? 2022 batch. So there must be some speciality about the batch. That batch used to be having good singers or dancers in that class, or some painters would be there who used to do good painting, or very good programmers in that class. So some special features also can be there for that electronics 2022 batch, right? So here inside that, maybe 2021 batch had different features, but 2022 electronics batch had some different features like co-curricular. Right? So co-curricular was an additional feature of electronics 2022 batch. Otherwise, all the other classes of electronics 2021, 20, 19, 18 would have all this, but co-curricular was an additional in 2022. Students were more very good in co-curricular also, right? So now we understood the concept of class, we understood the concept of objects. So object is an instance of class, class is a template. Now let's come to inheritance. Inheritance, we all know. Inherit. When see, inheritance is very simple. We as son and daughters, right, inherit the property of our parents, and the physical property of is the land and house and whatever it is, but also our characteristics or some qualities of our parents come to us also, right? Say we look little like our parents, right? So we inherit, we get them from our parents because of our genes or DNA. So inheritance is such a simple thing, right, to understand. So there is a parent class called car. Now BMW or Maruti would inherit the commonalities of the car, right? Properties of car is what? Driving and accelerating, braking, parking, right? These four. So inheritance is just to inherit the properties, data and methods. You can see this is how you should learn. Inherit the data and methods of parent class. Inherit the data and methods, right? So data and methods are the properties, right? A student has some data and the methods unique to those students. So if I inherit, if I inherit something from my parent class, that's called inheritance, right? Say for example, car was a class, public class car, right? I defined this, and then I had data, say name, or you can say string name, right? Then we would have string type of car, then string will have what do you say? Type of car, name of car, year of manufacturing, then string, color, right? String, here you can put date here. See how things come, date, right? Then integer, we'll say torque, right? Nowadays people are more worried about how much torque they, right? 120 is the torque, right? What is my integer? What is my x? This one, mileage, right? So these all are the data being held. And now we'll have methods also, right? So void, we'll say public void acceleration, right? This is the method, one of the method. Then we'll have similar methods, right? The car would do whatever the car has to do, right? Acceleration, then braking, then reverse, then parking, then one more method we will say what else one car would do. I think that's more than enough, right? So see, I created a class called car which had these many data and these many methods. Right now, object, what will be the object? Object would be public, I'll create a child class, public, another class I'll create, BMW, right? Inheritance I'm showing, extends car, right? So now what I'm doing, I'm creating another class which would have the same thing, but it extends car, it extends the parent, right? So parents properties will come. So these were the properties from parent. Now what will BMW do? BMW will have its own property also. So now we will give some new property to BMW. So BMW introduced a new concept called say, what was that? ADAS, right? ADAS is there. Then there are so many new properties which BMW gives, right? Screen, wide screen, right? Wide, maybe, what do you say? The display, right? Display name. There will be some display on the dashboard, so they give a new name to that. They have a very big display, and they introduced, say, auto reverse. Just don't need to change gears. Auto reverse. Just press the button, right? So they introduced so many new things, right? But it still holds the properties of its parent. Parent name, type, year, color, torque, and mileage would be common for all the cars, right? That would automatically come. But then I have my own properties, my ADAS, my display, my auto reverse feature, right? And then it would implement, it would also get to access these methods, this braking, reverse, and parking, right? But then also new methods I may not. So I will say high acceleration, right? I will implement my own method. BMW has its own high acceleration. Normal acceleration mode, if you run, it will work in city conditions. But on highway condition, when I press the button called sports mode, right, or cruise mode, right, you can say cruise. Instead of high acceleration, I will say cruise. So this new implementation of BMW, I'll remove the other one, right? So this is the new thing they have introduced in market. BMW introduced cruise. So what is cruise concept? We all know when the driver need not bother about changing the gears or accelerating. If it's a clean highway for 50 kilometers, just press the cruise button and you relax. Just you have to maintain your directions by using the handle. So BMW introduced a new method called cruise, but still the older methods of the parent, since it is extending your parent, right, it inherits implicitly. This will be applicable for BMW also, whatever objects BMW creates, right? So now I will say BMW B equal to new BMW, right? Now B dot cruise, CRUISE. So I'm calling my own method, right? That's so easy. But how do I call now parent method? So where was my parent? Acceleration. Acceleration, right? B dot parking, right? So you are able to implement your own, right? And you are able to call your parents methods also. And this gives what it does. You have created an instance BMW B equal to new BMW, right? This is an instance of your BMW class, right? This becomes the object, BMW object, and then you have implemented your own cruise method, and then you are calling your parent methods also, which is common to all the cars. So it's how the object would inherit the property from the parent, right? So you are taking the properties or inherit the properties from your parent class, right? So this is how inheritance works. Now let's come to encapsulation. So it's clear. Inheritance, just inherit the properties of your parent class. Let me check my office laptop. Give me a minute. It's pinging me. Okay, now encapsulation, right? Encapsulation is encapsulate, right? Encapsulation. See, when we send a letter, right, post letter, we put that in an envelope and send it. Why? Because we don't want our letter to get damaged, torn, right? So we put in an envelope and send it. So that envelope is an encapsulation. It tells you that it is a letter, but it contains. So it's called hiding the internal details, right? Encapsulation means you put a box around your object and you send it. You put an envelope around the letter. I see when Amazon delivers, it puts everything in a box, right? Flipkart delivers, it puts in a box and sends it to you. So that box encapsulates what is inside. So the delivery person will not know what is inside. He will just see the address on the box. Okay, sir, I'm coming to deliver. Are you there at home? Right? So the box is the encapsulation. It protects it holds the content, right? It holds the data and methods. Got it? So if you talk in our real world scenario, an Amazon delivery or a Flipkart delivery, the box is the encapsulation around the object, and the content inside that is what the data is, right? What is the data and the method inside that? There is some mobile phone inside the box, right? So the mobile phone is an object, and the name of the mobile, the type of the mobile, the memory of the mobile, and the different functions it performs, right? That mobile will perform. Obviously, if it is a iPhone, the camera quality will be good. So high quality camera feature would be there. That method will be there inside that box, but when you switch it on, it will start functioning, right? So we are safeguarding from others so that no one sees that, right? What is inside. So that's called encapsulation. So it is wrapping the data and code, right? So hiding the internal details, wrapping the data and code, right? So this is encapsulation. So how do you implement encapsulation? Simple, by implementing class and objects, right? When you create a class like BMW I created, I am not letting the parent class object and data and methods to access until I create a new object, right? So I am encapsulating directly. I don't know what is there. So this would be in a different class file, right? The previous parent class, right? And the next BMW class, when I'm writing, this would be in another class, in another .java file, right? Or if it is in the same Java file also, to access, it is not that we have to see with the eyes. It is how do I access those, right? To access those, I cannot access until I create an object, right? So creating an object, right, is called encapsulation. There is a mandatory rule that until you don't create an instance of your BMW, without that instance, you cannot access your parent's class data and methods, right? So when you create an object, the encapsulation automatically comes into picture. So now using that object, you can access your parent class methods, right? Now you can access the b.name also, b.type also, whatever was there in your parent class, you can access, right? So this is very basic. Encapsulation is like hidden thing, right? It automatically implicitly comes into picture when you create a class and an object, right? So class and objects implement encapsulation by default. So they hold the data and methods because they don't want to simply give it to people. You want to the parent class would say, you want my data and my methods to use, please go ahead and create an object of your class, extend me, then only you will be able to use my data and methods. So encapsulation would come into picture automatically, implicitly. So the person is forcing. The programming language is forcing us create an object, then only I'll be able to access my parent data and parent methods, right? So encapsulation is very simple. You don't need to, there is no special implementation of encapsulation. Now polymorphism. Polymorphism is an interesting concept. Polymorphism. So polymorphism is, see, morphing, right? Morphing is, what do you mean by morphing? In general world, morphing is you put an face of someone on another's body, right? You edit a picture, go to paint, take a picture of someone, put someone's face on someone's body, right? Picture. So that morphing is what? The person's which was there originally has been morphed into another person, right? So the same thing they have implemented in polymorphism. So polymorphism is you do different things. Do different things. Very simple, but interesting. How? Now, say polymorphism. How do you implement polymorphism in Java, right? How to implement polymorphism in Java, right? How do you implement? So, say for example, to understand polymorphism clearly, you have this calculator class, calculator, right, class. So it has properties would be different numbers, right? From 1 to 10, 1 to 9, 0 to 9, correct? Numbers from 0, 1, 2, 3, like that, dot, dot, dot. And then it would have add method, then subtract method, then multiply method, then division method, right? So all these methods would be there in the calculator class. Right, so now this is the data and these are the methods in the calculator class. Now, data calculator, does it perform only basic number addition or it will give you in decimal also, right? So it will give addition for decimal numbers also. It will give addition for normal numbers without decimal, right? Non-decimal and decimal both. So addition method int a comma int b, right? What it will do? Return a plus b, right? Now add float a comma float b, and then return again a plus b, right? So now the user wants to do addition. So this class is closed, right? We have written a class. So method is there called add. First method is taking integer, second method is taking decimal numbers. Now the user is saying I am creating an object of calculator class, right? Cal c equal to new cal, right? And then c dot add 1 comma 2 and c dot add 1.5 comma 2.5, right? So now see the difference. When I call this method c dot add, which method it will go? It will go to the first method 1 comma 2 because it accepts integer. So, and when I call the second with a floating decimal number, it will go to the float method, right? Add method which accepts float. So during our execution, when I execute this program, right, then during the runtime, it will decide, oh, the user is calling a method called add, but the parameters are 1 and 2, right? Now 1 and 2 is with method, oh, the first one, right? So the Java compiler during runtime, it it understands which method to call. First, for first this one, it will call this, and for second, it will call this. So internally, the JVM, Java Virtual Machine, right, calls the add method for the first one and add method for the second one. So there are two implementations of add, but on during the execution, during runtime, right, the Java compiler will understand and decide which to call. So this is called runtime polymorphism. Runtime polymorphism. Right? Runtime polymorphism. During execution or during runtime, JVM or the decides which method to call. Right? So this is runtime polymorphism. It is also called method overloading. Right? See, the same method, but we are overloading. We are saying based on my type of parameter I am passing, please decide. I will overload. I will change the parameter and I will, based on the type of parameter, it will decide. Method overloading, right? This is called runtime polymorphism. Now, there is another concept called operator overloading, which is also called operator overloading. Operator overloading, method overloading and operator overloading. There are two ways of doing runtime polymorphism. Operator overloading is also the same like plus, right? There is an operator called plus, right? So now this plus, when the person presses plus on the calculator, what actually should happen, right? So that also can be overloaded. Sometimes, generally plus does addition, but any person can change that implementation, right? The person says, okay, I just don't want to just do the addition of two numbers. I would take input of three numbers, right? So 1 plus 1 plus 1, right? 3. So the person implements that it accepts, right, 3 parameters instead of 2. So that's called operator overloading. So it is method overloading and operator overloading. These are called runtime polymorphism. So the same method is doing two type of job. Add is a method which has morphed into two forms. So polymorphism is changing the form, right? Do different things. Change the form, you can say. Okay. So very easy. Polymorphism. So it's clear, right? Polymorphism. Abstraction, inheritance, polymorphism, encapsulation. So just very simple concepts. Think in terms of your real life scenarios. Think objects, real life objects as objects, and the group of that similar objects as class. I told you students of that batch, one group, so that becomes one class. Car is a category, that's a class, right? Inside class, if you come BMW or hatchback, whatever, different types of cars becomes different objects. And then say flowers, right, is one category, is a class. But if you go inside, you will have different type of flowers and different functions of flowers, like flowers bloom.
Is our video is coming?
No, it is
No.
Oh,
your video is not visible.
Sorry guys, yeah, I had some network issues on my side. Extremely sorry. Okay. Yeah, so I was explaining about different OOPS concept, encapsulation, polymorphism, right? So polymorphism, we understood it is the way a different object behaves differently based on the type of parameter, based on the number of parameter.
Anil, share once again your screen, no?
Okay. Not able to see.
Your screen is stuck.
Okay. I'm sharing again. You're able to see now?
No, sir.
No, sir.
No.
No.
Let me rejoin. Okay. I have rejoined. Let me share my screen. Now?
No, sir.
No, sir.
Still not?
No, sir.
Yes.
No.
How come? What happened? What changed? I have not changed done anything. Still not loaded?
No, sir.
No, sir.
Your video is stuck.
It is stuck. Three, 4 times I have already done. Anyways, I mean to say, see, the OOPS concepts was our agenda for the day, right? So we have covered all the OOPS concepts. The most important are encapsulation, abstraction, polymorphism, and there are two other concepts also called association and aggregation. I think association and aggregation are, I mean to say, not widely popular also, but they are part of it. Any object-oriented programming language will have association and aggregation. Association is you are associated to your parent, right? You are associated to, if you are extending say to your parent class, means you are associated, you are linked. So that association property by default it comes, right? And aggregation is another object oriented programming concept where you aggregate is what you collect together, right? So those are the like not I mean to say widely talked about object oriented programming concepts, but they are part of it. Any object oriented programming will have encapsulation, will have abstraction. Abstraction is hiding the internal complications of the car, right? We don't know how many nuts and bolts are there inside the car, how many types of things are there inside the car which constitutes the car, but we can use the car, right? We just sit and drive. If someone knows driving, you just sit and drive. We don't know what in complexity of the engine is. BMW, Rolls-Royce, Mercedes, they have so complex car engines, right? But completely hidden from the user. Driver has to go. A driver is a layman, right? He is a very simple person. He comes, sits in the car, and he knows to change the gears, and he accelerates and go. So the hiding of that internal complexity or internal data and the methods is called encapsulation. Inheritance, you are taking the properties of your parent class, right? So your parent properties, your parent data, methods and the information data variables, right? So all those variables and methods of your parent also are applicable to you. You have their own new features also. As a son, I have my own different name, but the name type, which is a string, I inherit from my parent, right? And I give a new name to myself, but the property is still the name I'm inheriting, right? But I may have a different hobby, right? I may have some new feature in myself that becomes my own implementation. So I can implement my own methods, and I can also inherit my parents' methods using objects. Always remember that any parent data, if you have to access, you have to create an object, and then only you can access. Without object reference, you cannot access, right? Indirectly, you cannot access. You have to create an object reference. And then encapsulation done, inheritance done, abstraction. Abstraction is the same implementation of class and object is called abstraction. You abstract, right? You are, I mean to say, not showing the internal details, right? And then aggregation, I told aggregation is another property, and association. Association is you are associated to your parent, right? So this is what the object-oriented programming world is. So these all features together, they all, and polymorphism. Polymorphism, I forgot. Polymorphism has two things. One is runtime polymorphism and one is compile time polymorphism. The runtime polymorphism is during the execution, JVM, Java Virtual Machine, decides which different method I have to call. If it is two integers the user is calling, go and call the integer method. If it is a float method, it is the user is trying to call because the parameters are float, decimal numbers, right? So go and call the method which accepts decimal numbers. So based on the type of parameter and the number of parameter the user is using while calling, the JVM decides. So operator overloading and method overloading. Those are the two types of runtime polymorphism. There is one more concept called method overriding, which is compile time. So method overriding is, say car class has a method called acceleration, right? So acceleration method I have already defined in parent in the car class, right? Now the child class, which is extending car, also says I just don't want to copy my parents' acceleration method. I want to implement on my own, right? So he gives the same name, right, acceleration, but he implements the internal acceleration method, it will implement on its own. So that's called method overriding. You are giving the same name, method name, but you are implementing it. The child implements it. So during compile time, the JVM will, in case of method overriding, during compilation itself, we get to know, the JVM will get to know, oh, I have to call my child class method, not the parent class. Why? Because it has a method with the same name. Oh, see, it's a very simple concept. JVM first it will check acceleration is there in child class or not. If it is there, directly call that. If it is not there, then only go and call the parents acceleration method, right? So very simple. Parent class has acceleration method implemented to do some function. Child also has the same name, acceleration, doing something, right? So now during compilation, when the JVM compiles the code line by line, what is compilation? Compilation is taking the first line of your program, even the first line, right? The package, then import statements, then the public class name. So all these are the statements in the program, right? So every line by line, when the interpreter compiles the program or the compiler compiles the program, so during that compilation, the JVM will decide, the compiler will decide, oh, there is a method name. Let me check if it is there in the child class. Oh, the child class already has it. So I will not call the parent class now. So it decides and it informs to the JVM. Okay, JVM, let's not call the parent class because child already has it implemented and we have to use that. Because see, local, it is local. So Modi is promoting go local, right? So buy Indian products, or if you are in a state, buy the state products first, give implement to state people. So go local. Go local is the best thing. It helps the local people, the local economy, right? So we also should promote that. Similar concept has been implemented in runtime compile time polymorphism in method overriding. Method overriding. So method overriding, the car subclass, the child class has already that method acceleration implemented locally, right? Why should I call the parent class? Because I already have it. So if you have, say, resources locally, you will not import it, right? You will not go to another state or another country. You will use your resources, local resources. If you have good IT skilled people in Karnataka, you will give preference to local people, right? There might be a debate on this, but I think some preference, some quota should be there for local, because otherwise from other states people will come and they will take the jobs, right? So this is how the quota concepts are there. People support it, some people go against it, but whatever the thing is, you should have some preference to localization also, go local also. So as a whole country, if you see, we are promoting made in India products, right? So this is our Indian product. So as a whole country, you see, it's our local product. So our apples should come from hilly areas, our oranges should come from hilly areas. We should consume those products first. In case we don't have anything in India and we need it very, very badly, like any emergency medicines or any technology we want to import, right? Those things we should import. But our products which generally we eat and consume, right? Cars, whatever, so we should give preference to our local manufacturers. And so the same concept has been implemented in method overriding. Child class has the method, parent class also has the method, but since child class is already having it, go and call that method. Don't call the parent class method, because we are preferring local, right? So locally it is available. So why should I go and call the parent class? So let's use that local method. So simple, very basic. There is no complexity at all. Compiler, during compile time, it will understand, okay, there is already a method in the child class, use that method. Let's ignore parent class method at all. So that's it. There is no complexity at all. So this is how the OOPS concepts evolved. The OOPS concept have changed the world, right? So now all our future programming languages follow OOPS, right? Most of them. But because they replicate the real life scenario of data and the method. They group similar type of objects into one class. They hold data and they hold methods, right? I gave you example of students. I gave you example of flowers, cars, whatever you have in this world, we can relate and we can use create classes and objects, right? And objects of those instances, objects are instances of this class, and then you can access the data, which is variable, methods of your parent class, and use them, or you can implement it on your own also, right? You have your own properties, you can implement your own acceleration, you can have your own new properties, name of the car, type of the car, right? If you create say hatchback cars, right? A class. So hatchback cars class also, if I create a child class, I inherit all the properties of hatchback cars, but I may have a unique feature in myself, and I will implement that method, right? So that method will be new and unique for me only, not for other hatchback cars. So this, see, every company bring new features in the cars, right? So they implement the acceleration differently. They, BMW, Rolls-Royce, Mercedes, Maruti, Hyundai, Kia, whatever it is, right? So these all companies have acceleration as a car class. They have acceleration, right? But they implement their own acceleration, right? The engine, how the engine accelerates, their implementation is different, right? That's how the whole concept of OOPS concept have come and evolved. So there are so many new advantages, advancements which have come into OOPS. And I think Java, when it came, so Java brought this, there was a programming language called C, right? C and then C++. So the initial times, C++ was the first language which brought this OOPS concepts. And then the Java brought it in a way that people understood it more clearly. They would be able to use it more efficiently, properly, right? Easily. Ease of programming was brought in by Java. So that is why Java became so popular, right? Now there are other programming languages like Python, which is, I mean to say, becoming popular. JavaScript is also one of the language, right? Ruby, Python, Ruby on Rails, and so many other. Scala has come, but all of them, they evolve around these object-oriented programming concepts. There is no deviation at all. They work with objects and classes. Class is the template. Object is the instance of that class, of that logical form. So you give a structure, right? That structure is defined, is called class. Now what you put inside that class, right? Different objects, those are instances of that class. So they hold the property of the, obviously, class, right? So 2022 electronics batch, they hold the property that I belong to that class. But then as a student, I may have my own new feature. I may love dancing, I may have a hobby of painting, or I may be driving, I may be doing something, I may be a bike racer or a car racer, right? A photographer, or whatever it is. So objects, right, they follow the template as a whole of the 2022 batch, but they may have their own implementations, their own unique implementations also on their own. So that's the unique property that identify that object, right? But as a whole, if you see, they are still students, similar students, all go to the same classroom and study, right? So this is how the whole concept of class and objects came into picture. We all understood it. Any questions? Any clarification you want?
No, sir.
We are good. You should be clear, at least, I mean to say, say, if you have never worked with any programming language, then also object-oriented programming concepts are very, very handy, and you can relate also. So like example of students, example of class or flowers, we can relate, right? We can easily understand, oh yeah, class of a student, right? And then we have objects as students, which have their own properties, their own name, their own data with them. And then when we derive a child class, those class will take the property of your parent, right? Obviously, as a son, I inherit property of my father. Same way, BMW subclass will inherit the property of the car class, but implement their own acceleration. So it's so easy to relate. So all are real life things which were, I mean, to analyzed, and then these concepts were brought in, right? So that's it for today. I think we are good. Any questions you have, let me know.
No questions.
No questions? Good, very good. If you are understanding at least 10% of what I told, that's more than enough. Because see, these all concepts, right? We may not be actually using in automation. Automation mostly will be around strings, integers, creating classes and all are basic, right? So we will do those. But like I create a subclass of a parent class, all those things will not come into picture in automation, ideally, but you should know. So in automation world, we should be aware, oh yeah, this is a class, right? At least the concept of class and objects we should know, because we would be writing different methods, right? Those methods are very, like for example, when I have to click a method, click a button in login, right? When I am logging into Facebook or Gmail, so entering the user ID, entering the password, and clicking the login method, all these three I will combine and create a method called login, and I will call it every time, right? Every time the test case runs, this has to run, right? So this is a method. So I will group some of the actions inside one method and then use it again and again. So this is the concept of methods or functions. We also call them functions, right? So these functions we will be writing, right? And then we will use them. And so you should know how to write a class, how to call the methods, right? And I told you to call a method of your parent class, you have to just create an object. Without creating an object, you cannot call directly. So there is called reference. You have to have an object reference which says, okay, I am object, but I am extending my parent class. So that is why I'm calling my parent class method, right? So that's it. I think it's not complex things more. We'll meet tomorrow and we will directly go and start writing Java programs, right? Basic Java programs. So object oriented programming concepts is what was the agenda for the day. So any questions you have, you can ask, otherwise we are good to go for today. Tomorrow we'll write the first, I mean to say, around these concepts only, we will write few programs. But what I will do, I will try to use whatever the automation requires. Say I will create a string object, integer objects, float objects, because data, see, all our automation jobs we will do in future, right? We will have to work around data. So some would work with Excel files, some would work with an application, say, for example, any application you give, insurance company also, or a bank application, or anything which is there on the web application, right? It will have some data, right, to be captured from the website. So we'll have to capture those names as strings, numbers as integers, and decimal values as float values, capture them, whatever format, whatever we have to do some calculation, and then produce the result, right? So automation is what? Automation is validations. So the company is developing an application, a banking application or a insurance application. So some functions will be there, right? The application would perform some functions. So insurance functions will give a new insurance, renew an insurance, and then what? Claim an insurance. So these three are the basic things of insurance. So when I buy a new insurance, the person should get the quotation of the premium, and then he should be able to buy that insurance, right? Second, when the year completes, right, he should be able to renew the insurance. Third, when there is a claim, suppose it's a bike insurance or a car insurance, there is a small incident happened, so he wants to claim. So claim insurance. So these all three are flows. So now automation should validate these flows, whether the user, after logging into the insurance application, he is able to log in or not, he is able to see the home page or not, he is able to see the forms to fill the data or not, right? You have to provide your name, your address, your PAN card, your Aadhaar card, your ID card, whatever details is required, right, for to complete the buying of insurance. The whole flow the user has to validate. Similarly, the claim process, similarly the renewal process. All three parts, major flows of insurance needs to be validated. So automation has to do that. So automation is a very important part of the IT industry now. Earlier, manual testing was preferred, right? So lot of effort was used to do manually test the applications. But after the introduction of automation tools like Selenium, QTP, and so many others, right? We have so many tools available now. There is a tool called there was recently a new tool which is this one RPA. There is a new tool in the market called RPA. Almost 2-3 years, 4 years back, it was introduced. And what it does, it is robotic process automation. So what it does, it understands these flows, right? We record these flows, and say if the insurance buying process, it will log in. Also, it will record. It is like a recording, but not like Selenium IDE. Selenium IDE. Selenium also has a recording application, right? Selenium IDE, right, which records this all the user actions and gives you the script. But what it does, it has limitations. We cannot. It is little complex to parameterize. I always will not log in with the same user ID, right? I want to log in with different user ID. I want to do negative validations. I want to do so many other things. So RPA came into picture where these flows are recorded, and then automatically the tool will create scenarios for you. It will create positive scenarios, negative scenarios with different data, right? Positive with different data, negative with different data. So RPA came into picture, robotic process automation. There's a tool. This is a very widely used nowadays. Some companies are extensively investing on RPA also. So RPA is one of the latest tools which I was just talking about, where it records these flows and creates the scenarios for you on its own, and then you have a set of test cases ready, automated test cases ready to execute. No user intervention required. Only thing you might have to see whether the scenarios have been correctly built or not. That's it. Then click all the 15 scenarios it creates, it executes and gives you the report, right? But that's a tool. So you have to learn that tool, how to use it. There is not much programming involved, so there is no much control also is not there. So you have to go according to the tool. The tool you have to learn. You have to take a course on RPA, learn that tool, and then use that tool. So it is a type of, again, a limitation, right? But our Selenium and Java, if you know programming, if you know Selenium, how to use Selenium, then you can control. You can write how many scenarios you want on your own, right? And then run the regression batch. The whole regression scenarios will get executed in 15 minutes, say max, and you will have the report. So the control, when you know use Java and Selenium, the control would be more. There are so many automated tools available, right? Which will automate, which will record the flows and give you. But the control will not be there. The control will be with the tool, not with you. So if you want to control how you want to automate, then always go with Java Selenium or Python Selenium, whatever, right? So this is always better and evergreen, right? You don't need to be a tool user. You will say you will become nowadays, automation testers almost like developers. Though some of us might be from the non-IT, but if you learn automation and go further in future, you learn the advanced concepts of automation, design frameworks, right? Have a very strong hold on programming. You become developers. And now so many companies like PayPal, Amazon, Flipkart, big companies, right? There's Facebook, Google. They all hire IITians to do automation. Why? Because automation is not just writing few lines of code and executing it. It is a very vast field now. So those are called SDET, software developer in test, right? So SDETs are being hired. Developers are being hired for automation roles. So we have a very good future. So don't worry about it. Very interesting. you already have completed your manual testing course, so you know what testing is, what validation is, right? You have so many scenarios listed in an Excel file or any tool, right? So you have to test one by one manually. The same, we have to automate them. It is the same process but through scripts. So we will write the scripts and then we will test them and generate the report. So yeah, very interesting. So we will start with Java tomorrow. We understood yesterday and day before about Selenium. Today we got to know about the OOPS concepts. Now we'll move to the writing of the Java code. So tomorrow onwards we will use the basics of Java, string, integers, and see how classes are constructed, how objects are defined, right? And then we will try to do automation using those concepts. Instead of just doing plain Java, what I am planning is, I generally do is I use those Java OOPS concepts, Java programming concepts, and automate the things. Like, for example, yesterday we launched the browser, right? I'm not able to share my screen. Trying again. So yesterday when we wrote those 3 lines of code, right? Public class, first test, then we had a main method, then we had 3 lines of code, system.set property, then WebDriver driver equal to new cron driver, and driver.get. I already have given you the class, right? I have already given you the main method, and then I have created a new object of driver, right? Called driver equal to new chrome driver. Chrome driver is another class lying sitting somewhere, and then I am using that object to call the method called get. So you are inheriting all the properties of chrome driver in this driver object, right? And then you are calling the parent method which is there in chrome driver, right? Are you able to see my screen now?
Yes, sir.
Okay. See, now WebDriver driver equal to chrome driver, right? So now this is my class, but I am using an object of chrome driver, right? Which I'm importing it here. So my parent class, if I go inside this one, see, you have all the methods defined by your parent. See, all the methods are there. Set file detector, get local storage, location. All these methods are predefined inside your parent, right? So when I say WebDriver driver equal to new chrome driver, I have access to my parent's data and methods, parent information. And then simply using that object, I am calling the get method, right? The get method is, if I click on this, you can see the implementation. With what it does, it's one of the method, it does nothing, right? This is an abstract method. You have just defined that it takes the URL, right? So all these are abstract method also, but we'll have the actual method also which implements. So why it is abstract here? Because this also is coming from some other parent, right? So it will come from one more parent. So this is how the object-oriented programming is implemented. You have Chrome driver, but Chrome driver is not the only driver which wants to launch an application. Firefox driver also wants, right? And Chrome driver also wants, Internet Explorer also wants, Safari also wants, and Edge driver also wants. So the get method is so common that it has been written in the main driver, web driver class, right? Where it is web driver, the first web driver, then we have Chrome driver, then your class, right? So you are calling get, but the Chrome driver has get, which is abstract. It has not implemented because the parent of Chrome driver, which is web driver, has implemented and given it. So it takes that URL and it launches the browser and opens that URL. So this is the beauty of object-oriented programming. You have an object, you access your parent object, parent methods, right? So and use them. So this is how the class and objects are used. Very simple, right? Okay, I think we are good for today. Let's meet tomorrow. Thank you so much.
Thank you so much.
Thank you, sir.
Thank you. We will meet tomorrow.
Thank you, sir.
Thank you.